Hi everyone, let's continue. So example 4. A light is on the top of a 12 feet tall pole and a 5 feet 6 inch tall person is walking away from the pole at a rate of 2 feet per second. Part A. At what rate is the tip of the shadow moving away from the pole when the person is 25 feet from the pole? Part B. At what rate is the tip of the shadow moving away from the person when the person is 25 feet from the pole? Okay, what are our steps? Step 1, we want to draw the picture. Okay, so here we have the picture, we have the lamp right here, and we have the person right here. Okay, and here you see the variables we already given, right? XP is the distance from the person to the pole. XS is the length of the shadow, right? X is the distance from the tip of the shadow to the pole. Okay, and we can see XP prime is actually dXP dt. They're the same thing. So the person is walking away from the pole 2 feet per second. Okay, so here the picture and variable are given. So part A, what are we looking for? Okay, we're looking for the rate of the tip of the shadow moving away from the pole. So from the tip of the shadow to the pole, that is x. So that is dx dt. And when the person is 25 feet from the pole, so that is xp is 25. Okay. And part B, we're looking for the rate of the tip of the shadow moving away from the person. So that is dxs dt when xp equals to 25. Okay, so in order to get a relationship between the variables, okay, here we see some triangles, so let's give them some vertex names. Okay, so that's AOAB and OCD. Okay, we can see those two triangles, they are both right angle triangles. So triangle OAB is similar to triangle OCD. Okay, do you remember what is special about the similar triangles? The corresponding sides have the same ratio. Okay, i.e. OA over, when we don't use OA. So here we know AB and we know CD. So we want AB over CD equals to, here our variables xs and like x, they're like OB. Okay, then the corresponding sides of the other triangle is OD. Okay, because A corresponds to C, B corresponds to D. Okay, and so let's continue. So AB, what is AB? AB is 5.5. So 5 feet 6 inch equals to 5.5 feet. CD, what is CD? Oh, that is 12. And then, so here we are given dxp dt, and we want to find dx dt. So we want to get a relationship between xp and x. What is OB? Well, OB is xs, right? That's not what we want. We want to have a relationship between x and xp, but it's okay. What is xs? Xs is actually x minus xp. Yes. What is OD? OD is x. Wow. So we have the relationship between them. So let's simplify. Here we can cross multiply. We get 5.5x equals to 12 times x minus xp. So 5.5x equals to 12x minus 12xp. Okay, let's move the 12xp to the left. Now, so both sides plus 12xp, and then both sides subtract 5.5x. So 12 minus 5.5 is 6.5x. So now we get a relationship between xp and x. Okay, what's next? We're ready to differentiate, right? Implicit differentiation. Take the derivative with respect to t on both sides. And then we have 12 dxp dt equals to 6.5 dx dt. Okay, so what is dxp dt? That is 2. So dx dt equals to 12 times 2 over 6.5. So plot this in our calculator. So the answer is 3.692. Okay, what is the unit? Feet per second. Okay, so that is part A. How about part B? Well, part B, we want to find the rate of change of xs. So we want to find the relationship between xs and the other known variables, which is xp and x. What is xs? From the picture, we can see xs equals to x minus xp, right? And then we're ready to differentiate. So we take the derivative with respect to time. Okay, what is dx dt? From part A, we get 3.692. What is dxp dt? That is 2. Wow. So we do the calculation and we get 1.692 feet per second. So that finished the problem. Okay. All right. So don't forget that if you have questions, you can always print screen and ask me. Okay, let's go to the next one. Okay, example 5. A piston is seated at the top of a cylindrical chamber with radius 5 centimeters. So here the radius are, okay. So we know this is 5. And we know that is fixed. So we don't need to give it a variable because it's fixed. Just let's put 5 there. Okay, when it starts moving into the chamber at a constant speed of 3 centimeters per second. So you can see the height is changing. And what's the rate of change? Because it's moving down, right? The piston is moving down. So that's why the height is decreasing. So it's negative 3 centimeters per second. What is the rate of change of the volume of the cylinder? So our goal is to find the volume, the rate of change of the volume when the piston is 2 centimeters from the base of the chamber. Okay, that is when the height is 2 centimeters, right? So that is the first steps. We show the picture, name the variables for constant, just give a number, don't give it a variable for that. For the quantity that varies, we give it a variable h here. Okay? Step 2. We know dh dt and we're looking for dv dt, right? So what is the relationship between volume and height? Well, this is a cylinder, right? Cylinder volume, and this is a circular cylinder. So the volume is pi r squared h. But because r is fixed, is 5. 5 squared is 25 pi h. So that is the relationship between V and H. Okay, next, what do we do next? Yes, we're gonna differentiate. So dV dt equals to 25 pi. Well, dH dt, right? Wow, we're ready to plug in. dH dt is -3, so we get -75 pi. And what is the unit? Volume, so cubic centimeters per second. Okay, so that is our answer. If you want to plug it into the calculator, we can do that. So, what is it? That is about 235.62 centimeters cube per second. Okay, so that is example 5. Right, this example is easier than the previous one, right? Okay, let's continue. All right, so example 6. I really hope that before we go over the example, you can maybe first try to work on it before, okay? And then after you finish, we can check our answer together. Okay, so example 6. The bottom of a large theater screen is 3 feet above your eye level. Okay, so let's draw a picture. So here we have the theater, and this is the theater screen, right? The bottom of a large theater screen, the bottom, okay, is 3 feet above your eye level, and the top of the screen is 10 feet above your eye level. So let's see. My eye level is here. Okay, so that is my eye level. So the bottom of the screen is, oh, sorry, I think I drew it wrong. My eye level is here. Okay. My eye level is here. The bottom of the theater screen is 3 feet above my eye level, and the top of the screen is 10 feet above my eye level. Okay, assuming I walk away from the screen, perpendicular to the screen, so I'm walking away at a rate of 3 feet per second while looking at the screen. What is the rate of change of the viewing angle, theta, when you are 30 feet away from the wall on which the screen hangs, assuming the floor is flat? Okay, so it's asking the viewing angle is, let's say, that's the angle theta. That is the viewing angle. Okay? Alright, so that's the theta, and what is changing? The distance between me and the screen, right? So let's call this guy to be x because it's horizontal distance. Okay? So now we know dx dt is 3 feet per second. Okay? And our goal is to find d theta dt when x equals to 30. Okay, so that is the picture and the variables. So next, how do we find the relationship between theta and x? Okay, so can you see there are 2 right angle triangles? Let me use different color. Okay, let me use this one. Okay, so Alright, let's call this guy O. Let's call this guy A, B, C. Can you see there is a triangle? Okay. O, A, B. Okay, where this is 3 and this is X. Okay, and there is a triangle O, A, C, right? Where this is 10. Okay? And what is theta? Well, if we call this is theta 2, this is theta 1, then the theta is actually theta 1 minus theta 2. Right? So if we're looking for d theta dt, well, that's the same as we use d theta 1 dt minus d theta 2 dt. Right? So we need to find what's d theta 1 dt and what is d theta 2 dt. Okay, let's look at the first triangle. The first triangle, we know 3, we know x, and we're looking for theta 2, right? So what's the relationship between theta 2 and x and 3? So we know opposite over adjacent is tangent, but it's better to have the variable x in the numerator. So let's use adjacent over opposite. Do you remember what is adjacent over opposite? Yes, that is cotangent. So cotangent of theta 2 equals to x over 3. Okay, now let's differentiate. So derivative of cotangent is minus cosecant squared. Derivative of x over 3 is 1 over 3 times dx dt. Oh, I forgot something. See, I forgot d theta 2 dt. Okay, so now let's see. At the moment when x equals to 30, what do we get? So now let's try to plug in, right? At the moment when the x is 30, okay, what is cosecant? So by the way, here we have 30 squared plus 3 squared. That is square root of 90. Let's see, 909, right? 30 squared is 900. Okay, so cosecant is what? Cosecant is cosecant is 1 over sine. Sine is the opposite over hypotenuse. So that's why cosecant is the hypotenuse over opposite. Okay, so hypotenuse squared, which is 909 over opposite 3 squared is 9. Okay, and then we have d theta 2 dt is 1/3. dx dt is 3. Oh, so d theta 2 dt is actually, so the 3 cancel, we have negative 9 over 909. And that is, we can cancel the 9, we get 101. Okay, that is d theta 2 dt. Okay, how about d theta 1 dt? Okay, let's repeat the same process. So cotangent of theta 1 is x over 10, right? And then when we differentiate, we get minus cosecant squared. Theta 1 d theta 1 dt, right? Don't forget chain rule, because we're looking for d theta 1 dt. If we don't put it down, oh, how can we solve it if it doesn't exist, right? Okay, so this is 1 over 10 dx dt. Okay, so what is that? So let's see. At the moment, when x is 30, okay, that's 10. Then the hypotenuse is 30 squared plus 10 squared. Wow, that's 900 plus 100, 1,000. Okay, so cosecant. What's cosecant? 1 over sine. So that is the hypotenuse square over the opposite square. Okay, and d theta 1 dt equals 1 over 10. dx dt is 3. Okay, here you can see this cancel. So d theta 1 dt is negative 3 over 100. Okay, finally, d theta dt is d theta 1 dt minus d theta 2 dt. d theta 1 dt is negative 3 over 100 minus negative become positive 1 over 101. Okay, so approximately equals to, let's put this in our calculator. We have 3, so negative 3 over 100 plus 1 over 101. That is approximately equals to negative 0.0200, so 99. Okay, and what is the angle of the what was the unit of the angle? Yeah, radian. Okay, radian per second. So that finished our problem. Okay, all right, so if you have any questions, feel free to ask me. Bye.